with our databases course that you're all here for, and I know you're all desperate to get started. So before we do properly, I'll remind you that if you have any questions, you're welcome to use QChan. Now, I sense we're all going to get on really well because I love the fact that you all hacked the crap out of it on Tuesday. I used hack in an advisory session. Obviously, I failed to input sanitize the nicknames, which was good. I sanitized the messages, but who'd have thought? So there was marquee text, JavaScript injection. I imagine my bank details are now with one of you guys. So if you could pay off my overdraft, that would be very generous of you. So feel free to carry on use QChan. If anyone wants to have a go and try and break it or whatever, please do so. What I would say, though, is that this room, the 1023 room, if you fill it full of messages, it's just going to get very difficult for us to find questions. So if you join using the code LEET, L33T, you can join an experimental room where you can do whatever you want. Also, somewhere in the back of all of this at a server is a WebSocket server, which handles all the exchange of messages. I imagine that at some point that's going to blow its brains out and die. So if you want to try and break it, that's fine. Do it outside of lectures. If you find a bug, you've got a suggestion, something like that, email me, and great prizes will be yours, by which I mean no great prizes will be yours. But, you'll have the honor, you'll get a mention, and, you can feel the enthusiasm of the job well done. If any of you don't have access to the QChan, want to ask questions, you should have all got an email about it. If you still don't, then drop me an email, and we will go from there. So today we're going to start looking at databases in more detail. We're going to talk a little bit about the different levels of design. So I sort of mentioned to you that when we're building a data-driven system, we're building a database for the real world, we start with an imperfect model. We start with a real thing. We usually want to model something that we're going to do. And we start with the conceptual essence of it. What is the thing that we're looking to model? What are the entities contained within it? We then move on to logical and physical design. So we start with the kind of real world, identifying what are the things we want to record. We then start thinking about what attributes do they have, numbers of fingers, numbers of toes, that kind of stuff. And then eventually we move into the physical design, which is where we actually start putting code to paper. We actually start building a database as we go along. So we're going to talk a little bit about that, and then we'll talk about entities, and we'll talk about relationships between entities. So this is generally the kind of different levels of database design. So you'll see that we have here a whole bunch of different things that we can do. So, from entities, attributes, keys, column data types. And we start not doing very many of those. We start at the conceptual end. What's the business domain that we're interested in? Really, we're only interested in what are the entities and what are the relationships. We move on to the logical design, and we start looking at more and more details right through to what are the keys, how are they related to each other. And then finally, we get to the physical design, which is where we need the whole lot. And that's where we actually start writing a schema, SQL, that kind of thing, and sticking it into the actual database to be implemented in order to go. So today we're just going to be having a look at names and a little bit about relationships between entities. Now, a lot of this stuff is fairly simple, but it's also fairly critical. These kind of things that you decide on when I'm designing a new system, what are the entities involved, how are they related to each other, absolutely influence all of your decisions later on. The complicated bit in database design is really not writing SQL. That's easy, especially for nerds like us, that we live and breathe code. That's the easy bit. The complicated bit is making sure that we've got the entities right, we understand the relationships between them. Because if we don't, what happens then is we make a small error at the start, and by the time we've implemented it, that's become a huge error because we've made a mistake in the requirements analysis. So it's the same with any kind of coding or any kind of technical task. We pay attention at the beginning because little errors at the start, by the time we've worked on those, we've turned those errors into requirements, into designs, into implementation, those errors then become much larger and much more difficult to fix as we go through it. So what's an entity? What do we mean by an entity? So an entity basically is a thing with a distinct and independent existence. An entity is a single person, a place, or a thing about which data can be stored. So an entity is a thing. Merriam-Webster, an entity is independent, separate, or self-contained, so a very similar definition. The existence of a thing is contrasted with its attributes. Something that has a separate and distinct existence. So we have a few common themes then in all of these definitions. So, distinct thing, independent existence, about which we store data. Now, in database terms, we talk about a logical thing, not an instance. So an entity is a template, a bit like a class in Java. It's the class, not the instance, the implementation of it. So dog is an entity. Fido is an instance of that entity. An actual dog, one dog, that's an instance. The idea of dog, the concept of dog, the conceptual essence of dog, and the collection of things that we know about dog, breed, legs, cuteness, does it bite, all these kind of things, these are the attributes of the entity as we go through and do it. So depending on what kind of system you're building, you might have a lot of different types of entity, and there's lots and lots of different examples. Generally, an entity is a common class of thing about which we store data. So student, in a university example, car, cat, TV, module, assessment, account, customer. All of these are potentially entities within our system. These are things that we will store data about. They exist. There is data associated with them, and they are independent of each other. They are a thing that contains it, so they meet all of our definition and criteria. Okay, so let's have a go. So think about a school. If we're modeling the data structure of a school, what would be the entities that you might identify? Okay, so take a couple of minutes, have a think, answer on QChan. Is it still running, which it seems to be? So cringe, I know I am, but you know, what can you do? So have a go on that, couple of minutes, all right, post your answers on QChan, and then we'll have a look at those in a second. So think of a school, what are the entities that you would have if you're modeling a school? Okay, I seem to have a natural lull in the conversation there. So let's have a quick look at the serious answers that everyone has come out with on here. So some of them are, you know. Students, borrowers. So I think we're talking about books there. Expensive books, people have books. Students and staff, teachers, grades, results, dartboards, guns. Not so much over here, not anymore, as I'm led to believe. That's what they told me when I came over. Okay, so yes, some good examples. So a school, what are we going to have? We're going to have students, people identify those. Will we have teachers? Are teachers the only type of staff that we'll have in a school? What other types of staff might there be? Teaching assistants, janitors, headmasters, these kind of things. So we probably actually would have staff as a specific entity, maybe separate to teachers. Classes, yes. Certainly in secondary school, you would have individual classes that people are members of. And then other relationships, things like marks, assessments, like people have said, grades, indeed, to come and do it. Frustrated lecturers, I think it's university more than school. And lots about shooters. So there we go. All right. So yes, okay, so a good start, absolutely. So we're going to take a moment, you know, when you took a moment, you look back, you think about what's in a school. It's reasonably straightforward. We're identifying entities. Entities are things. It's a class of thing that you would deal with. So in a school, teachers, students, probably parents. You probably have records of parents, wouldn't you, to ring them up and tell them little Jimmy's been sick again and suspended or whatever. So you have these kind of things. So you start thinking about entity identification. So the identification of entities is the first thing we do. We go through, we look at a given system, a given domain, and we say, what are the entities that we're going to deal with within this? The second thing we want to do is we want to map out what we call entity relationships. So these are how the entities relate to each other in quite a simplistic way. So after we define the entities, the database we want to build, we need to work out, first of all, is there a relationship between these entities? And secondly, what is the type of relationship that exists between them? And the way we map these out, the way we help conceptualize them, is we draw a thing called an entity relationship diagram or an ERD, which are absolutely awful, we have to cover anyway. Who has done entity relationship diagrams before? Yeah. Who likes entity relationship diagrams? Okay, who thinks they're sort of Satan's best friend of complexity? Yeah, okay, yeah. So we are going to cover ERDs, unfortunately. And one of the things that I'm also going to make clear to you, and you're going to discover as you go through this module, and also next year, because next year you will take up a module called Information Retrieval or Information Management, which is taught by my colleague Deepak. And this is a feeder module for his. You know, we'll cover the kind of things, he'll cover the same kind of topics, but in much more detail. What we've discovered in comparing notes when we set up these modules is that there's about 15 different ways of representing entities and entity diagrams. There's no common standard, unlike, say, UML. So what we're going to do is we're going to have a look at one standard today, and later on in this course, we're going to have a look at the 3-ish most common ways of representing data, and it's useful for you to know. Okay, so we've identified the entities. We know there's relationships between entities, so we're now going to go and map these out in an entity relationship diagram. So the format we kind of use is we have entities as square boxes, entity name in a rectangle, and then some kind of line that connects them to represent a relationship between the two items. So car and owner, they have a relationship. We'll worry in a minute about what's that type of relationship, but we know that they're going to have a line between them. Computer science is all full of stupidly complicated words. We have a big problem because we are a very crap science. When I did my PhD in computer science, I worked in a lab, and one of my best friends was doing chemistry and used to hit me every time I called it a lab because she called it an office. We put science on the end and we like to pretend that we are, you know, doing science, and we are, all right, I'm not knocking it, but we seem to overcomplicate things. We put lots and lots of words in. So in a lot of computer science, it's all about words that we could just use simplistic ones. So when we talk about how things are related to each other, the word we come out is cardinality. It's the number of relationships, the numerical relationships between the relationship between two items. Cardinality. And there's a lot of these words. All the way through computer science, you'll come across a lot of these words that when you actually understand them, you think probably we could use a simpler explanation. But cardinality is what is used, and it's commonly defined. So the cardinality of relationships is the numerical number that we put on between relations. On one end, we can have a one-to-one relationship. One of this entity relates directly to one and only one of another entity, and likewise that entity relates back to one and only one of this. So we might think, and it's often a struggle in the real world to find a one-to-one, but we might say, my driving license. There is one driving license that relates to me, and I relate to one driving license. We have a one-to-one relationship between us. A one-to-many relationship, on the other hand, is that one entity on one side is related to one or more than one on the other. Okay? So I am here, I'm lecturing you now. There's one lecturer, there is more than one student, but the students relate to one lecturer as we go along. So one-to-many is quite a common example. When we can have one-to-many, we can also have many-to-many. More than one entity on one side relates to more than one entity on the other side, and vice versa. Students and modules. Every student can have multiple modules, and every module can have multiple students. Books and owners. You can own many books, and each book could be owned by lots of different people. Lots of different many-to-many relationships in the world. And so the way in this diagrammatic form, information retrieval modeling, that we diagramize them is as follows. So if we have this sort of simple-ish example, where we have a bank branch or whatever it is, I can't remember what it was supposed to be, but you have a branch, staff, each staff have parking space and a customer for the branch. We can say, okay, so the branch has 0 or more staff, but every staff member relates to one branch. Every parking space relates to one staff member, and a staff member might have 0 or 1 parking spaces. We'll have a look at these in a bit more detail. And I don't know why everything jumps around. And every branch can have multiple customers, and every customer can bank at multiple branches. So we have one-to-one, one-to-many, and many-to-many relationships represented within that. So let's have a quick look then at those specifically. So you might have noticed, obviously, there's various arrows and boxes and lines and all this kind of stuff in there. This comes down to the difference in ways of representing this information in ERDs, and we will, as I say, over the next couple of weeks, we'll have a look at one form, and then we'll come back and we'll have a look at a few of the other most commonly used ones. The reason why it's important to understand the differences in entity relationship diagrams is I guarantee you learn one, and then your first job on placement year will be to work with another format. So we'll try and cover them all in some detail. So often we need to specify things. We go beyond one or more than one. We actually want to say one of this has many of that, and is it one or is it at least one? So I might have 0 or 1 driving licenses, but every driving license must have one person. If a driving license exists, it can't exist for no one. Therefore, it must be tied to a person, but a person doesn't have to have a driving license. So we need to be more specific, and we can sort of say a branch has 1 or more staff. Can a branch exist if it has no staff? Staff can be assigned 0 or 1 parking space. A parking space is assigned to 1 staff member. And when we are doing this entity relationship diagramming and we're planning out how we're going to represent the data model, the challenge is to ask ourselves constantly, is that right? Is it true? Does a parking space definitely only belong to 1 member of staff? What happens on a Tuesday when that member of staff is off? What happens if that member of staff leaves? Are there some common spaces? And decisions we make now in correctly mapping the entities and correctly looking at the relationships will serve us well later on. So there are a few different types then of relationships. So here we go. This is a standard sort of one-to-many. So each A can have 0 or more B relations. So the more is shown by this kind of forking foot here, and the fact that it can be 0 is shown by this white circle on the end. So every A relates to potentially 0 or more than 1 B. But each B must have exactly 1 A relation. The line goes down, it doesn't fork out at this end, and we have a line here across which shows that it goes. Okay? Don't worry too much about memorizing these. We're going to show them. You've got the lecture notes, and we'll practice them until you're sick to death of it in various practicals as we go along. If we want to change this, we want to say here, okay, so here what we're saying is an A has 0 or more Bs. What happens if we say an A must have at least 1 B that it's related to? That's fine. We can change this, get rid of that circle, and put a line at the end. So the relationship the other way still remains the same, but now we're saying that every A must have at least 1 B, and it might have more than 1 B. So let's think about a class in a school. A class can't really exist if there are no students on it. So we might say it must have at least 1 student to exist as a class, otherwise it can have more than 1 student as we go through it. one-to-one, each A can have 0 or 1 Bs. So they don't have to have a relationship, but it could have 0 or more than 1. And again, when you see in this notation style, the little 0 come up, the little O at the end, that means simply can have none. Sometimes, even on this style, you'll see differences, and you'll see different ways of representing. This is an enforced one-to-one. Every A must have one B, and every B must have one A. There must be a relationship between them, they must exist, and they must be contained correctly. We can also, by putting numbers on, and you'll see this later on in the course, specify all sorts of weird things like, oh, each A must have between 2 and 5 Bs on a Tuesday or whatever in order to put on. But these are the simple kind of constructs that we would use in order to put it in. And finally, the many-to-many. Every A may have 0 or more Bs. Every B may have 0 or more A's. So there's no requirement for them to be related, but they can, and they can have an arbitrary number of any number of relationships on both sides of the entity. And as I say, you will get plenty of practice in this. Let's have a look. Anyone ask any questions? Do I want to play Fortnite? No, thanks. I don't really like Fortnite. Is it any good? The true story behind Madeleine McCann's disappearance. No, thanks. I think maybe. Okay, dun, dun, dun. That's good. Only just seems to be general chat. Peekaboo. People are swearing on here now. That's deeply offensive. Okay, no one's actually asked any questions. There we go. Okay, all right. Good. All right, well, I'm glad you're chatting to each other and finding useful. I'm sure you've got about 15 side chats going on anyway. Right, okay. So that's the basicness of entities. We have a name, we have a relationship, they go between them, and that's it. And these are the standard forms that we use with information retrieval notation to pick them up. So, hands up, who's used notation like this before for entity relationship diagrams? Okay, who's used the ones with the diamonds in the middle before? Yeah, okay. Who's used ones with little diamonds at the end next to the entities like UML before? No, okay, that's good. All right, okay. So, hopefully, and the reason I prefer this notation than the diamonds and the double lines and all of that is this makes sense to my really stupid brain. You know, I have a line and it goes to many. Oh, that's a many. Like, I don't have to worry about which way arrows go and what happens. So this is why in this module we'll primarily be using this form of notation to go through. You know, just remember it, the two rules. If it's a one, it's a line. If it's a many, it branches out. If you want to say it's enforced, you put a line through it. If you want to say 0 or, you can put a circle on the end. So those are quite simple rules that then make, hopefully, our lives a lot easier to do it. Now, sometimes we want to go further. Sometimes what we want to do is we want to express more complicated relationships. And so we might want to put verbs into the diagrams. So, you know, here we have a human and a doggo as our entities, and we want to be able to express the relationship that exists between them. And we can do that. Oh, that's a lovely doggo, isn't it? We can do that. We can express it with a line. We say, okay, a human can own 0 or more doggos, and each doggo must have one human owner. Not strictly true. Dog can have more than one owner. Dog can have no owners. Dog can live free and happy in the streets, but, you know, often doesn't. But this is a base relationship. We say that, you know, a dog has an owner, but someone can have multiple dogs in the same way in which, you know, later in life I can have many cats to keep me company. But what we might want to do is specify this. So we can actually put verbs, we can put action words into the diagram. So we take our standard form of diagram and we can stick on, so we can then say, okay, a human owns this way and a dog is owned by that way. And that allows us to clarify with verbs exactly what is happening and what we can do in order to do it. So if we revisit our kind of branch, staff, parking space, customer example, make this a bit clearer, we can stick some verbs on. So we can say, okay, a customer banks with a branch provides services for a customer, Branch employs staff. Staff works at a branch. Staff is assigned a parking space, and parking space is assigned to staff. So this can help us by putting a few verbs on, a few clarification words. This can help us, especially when we have a more complicated relationship, specify what goes on. If we have person and car, for example, and we just have a relationship between them, it's not obvious whether that person is driving just the car, owns the car, leases the car, rents the car, does whatever. So we can put verb action words in order to do that, to put different things in. Okay, so let's have a little bit more practice. We got time to do this in here, haven't we? Yes. Okay, we'll run nice and early, so we'll finish early today after we've done these. So let's have a think. First of all, right, so exercise A, university example. For the following entities, sketch out an ERD with cardinality and verbs as needed. So have a go on that, and then one of you, luckily, can come down and show us your ERD on the big screen for extra points. So have a go doing that. Okay, how are you getting on with that? Anyone think they've got something half good decent? No? Anyone got anything they want to come down and show? You can use the big screens. While you are finishing off, there were a couple of genuine questions in amongst the huge volume of spam on the chat channel. Someone asked, how do you draw an ERD on a computer? Someone else did answer, actually, my default answer. There's a very good utility called draw.io, which is free. It's available, it's a browser-based version, or you can download it, integrates with online things. Really, really good for entity relationships. These early lectures, I actually use a thing called Asta, which is a professional bit of software. However, later on, you'll see that I use draw.io, and I prefer that the majority of the time to work. Some people use Visio, God help them, and other people use PowerPoint. But draw.io works incredibly well. I love it for all sorts of diagram purposes. So another person asked very smartly, if you want to stand up and take credit, H1999 asked, surely on a computer you can't do a many-to-many relationship. We have two entities, and we want to represent that each one can reference many of the other ones. And you are absolutely correct. When we come on to look at implementation, when we go on from talking about entities to talking about tables, how do we actually represent this thing in the real world? What we will need in the middle is a link entity or a link table in order to work. Now, there are some exotic, fancy, newfound database engines which will let you create what appears to be a many-to-many table, but what will happen in the background is it will create a link entity there somewhere. And if you think about it in terms of actual filing, if you think, okay, so you have a student number, the module has a module code, how do we record in a physical file system that many students are enrolled on, many modules, whatever? We'll have another index card, won't we, of enrollments where we store the student number and the module code that goes on. So that's exactly what happens. That was a great question, so I'm glad someone has asked a good question. Two good questions. It's two more than I could have ever hoped for. So let's have a look. So look, we've got this here. We've sketched out the university example. Does anyone want to come up and show us their ERD quickly? Anyone feeling brave? Oh, I was going to pass you straight now, here and now if you came up. Never mind. Okay, right. So let's have a look. So we're talking about student, lecture, module, transcript, whatever. Okay. And obviously you can finish this off tonight and you can look at it. But let's have a think. So is there any relationship between student and lecturer? I mean, I'm not talking inappropriate relationships. Is there any entity relationship? But there's policies on that, I'm told. Between students and lecturers, do you think? Yeah? Hands up for yes. Okay, hands up for no. Okay, so the yeses have it, all right. So there are relationships between student and lecturer. I've got to be careful with this, haven't I? We have things like personal tutees. All of you will have a personal tutor. Some of you will have me, God help you. Don't ever come to me with your problems. I'll just tell you about mine, and they're worse. Okay. Is there a relationship between students and modules? Yeah? Yeah, okay, so there is a relationship between student and module. We're not going to map these out fully, because otherwise we'll be here all day, but there is definitely a relationship between them. Students have multiple modules, have multiple students. Students have multiple lecturers, lecturers have multiple students. It's all lovely many-to-many relationships. Is there a relationship between module and transcript? Yes? No? Utterly unsure? Okay, so there were a couple of people who said no, I don't think anyone said yes. I would agree that no, there's no direct relationship between them. So let's have a look at that in a little bit more detail. So students have a relationship with the module, right? And I would say that there's a relationship between module and assessment. Okay? So modules have assessments. Many-to-many, I won't worry too much about the cardinality at the minute. So modules have assessments. An assessment has a submission, which isn't really represented there, but an assessment will have a mark. that mark will be for an assessment. One assessment should have 1 mark. 1 mark should be for 1 assessment. And 1 mark should be for 1 student, but each student will have multiple marks in order to come out and do it. The mark, I would guess, and there's different ways of doing this, the mark has a relationship to the transcript. A transcript has many marks, and each mark generally might appear on more than 1 transcript. So when we say, okay, does the module have a relationship to the transcript, it doesn't directly, but again, what we're thinking about here is ways of linking entities together. So we would say the module has an assessment, the assessment has a mark, and the mark appears on a transcript. Does the transcript have a direct relationship to the module? No. But the transcript can still show the module, and it still knows what happens in order to go. Happy days. Anyone got any questions in here on this now? Everyone eager to get away early today? Yeah? I don't know, sometimes I almost think you don't even want to be here with us. Okay, so I don't think there's any questions on here. Hashtag relatable Dave. Oh, it's the first time I've heard that. Right, so look, have a look at that. Have a look at exercise B. Don't do that now. Do that at home because I know you've got exciting things that you want to do there. When we come back on Tuesday, we'll have a look at A and B as the solutions and go through. So please do take your time to have a look at it. Remember that practicals start on Monday. Some of you will be in at 9 a.m. on Monday. I will be there. So I expect you to be there. All right? And I'll see you all. Have a great weekend. Bye-bye.